Hey everybody, welcome to 9.5b. In this lesson, we're going to look at another piece of the quadratic equation in more detail, known as the discriminant. And then we're also going to derive the quadratic formula together as well. So make sure you have a piece of paper out with the section number, the date, and the I can statement, and then resume the video as soon as you are ready. All right, so we're going to start with the discriminant. And the discriminant shows the number of solutions for a quadratic equation. The discriminant is the section under the square root of the quadratic formula. It's the b squared minus 4ac part. And the cool thing is, if you calculate the discriminant first, you can know how many answers you're supposed to have before you actually do the quadratic formula. And it can also make doing the quadratic formula itself faster. So let's take a look at this for a sec. So the first thing to think about is what happens if the discriminant is less than 0. And if you think about this, if the discriminant, the value inside the square root ends up negative, we've talked about that we can't have real solutions when we take the square root of a negative number. So if the discriminant is less than 0, that tells us that we're going to have no real solutions. We don't even need to do the quadratic formula at all, because once we calculate the discriminant and find we have no real solutions, we're done. So this actually saves you a lot of time if you do the discriminant first and check this. Now, the second one is b squared minus 4ac equals 0. And if you get exactly 0, notice what happens. So if we have exactly 0, the whole square root part of the discriminant would disappear, and we'd be left with negative b over 2a, which is the equation for the vertex that we learned way back in chapter 8 when we were learning how to graph quadratic functions for the first time. And think about what's going on here. If the discriminant disappears, the plus or minus also disappears. We only have one solution because there's no longer a plus or minus. And we've talked numerous times that when you have one's x-intercept, the x-intercept also happens to be the vertex, which is why we can use this equation, negative b over 2a, to find the x-coordinate of the vertex, because what we're really doing is we're finding that single solution. So this is where our x equals negative b over 2a equation is actually coming from. Now, our final outcome would be if b squared minus 4ac is positive. And in that case, we're going to have two solutions because we're going to have negative b plus the square root and negative b minus the square root. So if we have a positive discriminant, we'll end up with two solutions. So let's see what this looks like in practice here. So I've got three examples. I want to do the first one and then have you try the other two. So one thing to notice here, before you can calculate the discriminant, you always have to be in standard form first. So that's something to remember. So in this case, a equals 1, b equals negative 5, and c equals negative 3. So if I find the discriminant, b squared minus 4ac, in this case I would have negative 5 squared minus 4 times 1 times negative 3, which gives us 25 plus 12, which equals 37. So what that tells us right away is we know we're going to have two solutions. Now the cool thing is, once you've found the discriminant, the quadratic formula is really fast, because our quadratic formula is x equals negative b, so negative 5, which is just 5, and then it's plus or minus the square root of the discriminant, plus or minus the square root of 37, all over 2 times 1, because a is 1, which is 2. Boom, quadratic formula is done. So it's really nice because if you've done the discriminant already, not only do you know how many solutions you're going to have, but it makes the quadratic formula really fast. The only thing you have to check is to make sure that that square root can't be reduced further. Now in this case, 37 is a prime number, so there's no reducing that's going to happen here, but if it was divisible into two numbers where one was a perfect square, you have to make sure you simplify it. So what I'd like you to do is take a moment, pause the video, try 2 and 3, see if you can find the discriminant and then find the solutions if there are any, and then resume the video as soon as you are ready. All right, so for number 2, first thing is we have to get everything on the left side. So we would have 4x squared minus 4x plus 1 equals 0. So we know a equals 4, b equals negative 4, and c equals 1. So for our discriminant, b squared minus 4ac, we're going to have negative 4 squared minus 4 times 4 times 1, which simplifies to just 16 minus 16, which equals 0. So our discriminant is 0. So that tells us that we're going to have one solution. And it also tells us that, so if we want to find that one solution, we do x equals some negative 4 is 4. And then it's plus or minus the square root of 0 all over 2a, 2 times 4. So this just simplifies to 4 over 8, which is 1/2. So our one solution, our one x-intercept is 1/2. And remember that tells us that that's also the axis of symmetry where the vertex is as well. So it gives us a couple pieces of information there. So then finally for number 3, again, we put it in standard form, so negative 5x squared plus 8x minus 9 equals 0. And then we know that a is negative 5, b is 8, and c is negative 9. So when we find our b squared minus 4ac, we're going to have 8 squared minus 4 times negative 5 times negative 9. Which in this case is going to be 64, and it's 3 negatives, so we know it's a minus, and then 20 times 8 is 180. So that gives us negative 116, and at that point we would just say no real solutions, and we're done. We don't even have to do the quadratic formula at all, which is what's so cool about finding the discriminant first, is it saves you a lot of time and effort. So that's the last piece that we're doing in terms of making the quadratic formula more efficient. The last thing I want to do in this video is show you where the quadratic formula comes from. So this is going to be the only derivation we're going to do in Algebra 1. A derivation is where you basically prove that an equation is true. You're going to do a lot of this in geometry. I will tell you guys right now that what I'm about to show you will be the extra credit problem on our chapter test. So if you can follow this derivation and then reconstruct it on the chapter test, that will be the extra credit problem for the chapter 9 test. So our goal here is we are going to start in standard form. And our goal is to show where the quadratic formula comes from. And the way we're going to do that is we're going to complete the square in order to create the quadratic formula. So if we think about our steps for completing the square, the first step is we need to move c to the right side. So we have ax squared plus bx equals negative c. Our second step is we need to factor out a. And the way we factor out a is we put a on the outside, we have x squared, and then if you think about it, if you take an a out of bx, you're left with bx over a. Because this way, if you were to multiply it back in, if you were to redistribute the a, you would come up with ax squared plus abx over a, and the a's would cancel out and leave you with bx. So this is how we factor out a when there was no a to begin with. So then our third step is we need to find the value to complete the square. So we have a times x squared plus bx over a plus something equals negative c plus something. And remember, our value to complete the square is always the b over 2 squared. Now, for this problem, our b value is actually b over a, because it's coming from right here. So b over 2 squared would become b over a over 2 squared. Now, b over a over 2 squared, it's easier to just write this as b over 2a squared. We can just combine those denominators. So then we have b squared over 4a squared if we distribute the square to each part. So that's the value that we're going to put in to complete the square. B squared over 4a squared. So I'm going to add that in, b squared over 4a squared. Now on the right side, we have to remember to multiply it by a. So we can think about this as ab squared over 4a squared. So our next step then is we need to factor on the left and simplify a little bit on the right. So on the left side, we would have a. Now remember, our factor is always x plus b over 2 squared. And our b is b over a, like we talked about earlier. So b over 2 would just be b over 2a squared. And then on the right side, notice that our two a's cancel out. We have an a here and an a squared, which could just become a. So on the right side, we're going to have negative c plus b squared over 4a. And believe it or not, we're actually getting a lot closer here. Because now we can think about, we want to combine the two terms on the right side. And to do that, we need a common denominator. And in this case, our common denominator is going to be 4a. So I'm going to rewrite the left side, x plus b over 2a squared. And on the right side, we need to multiply top and bottom by 4a. We're going to multiply by 4a over 4a so that we can combine our like terms. So negative c times 4a is negative 4a, let's write this in blue, negative 4ac, and then over 4a plus b squared over 4a. And we can even make this a little bit simpler because we can just combine those two. So we can have a times x plus b over 2a squared equals negative 4ac. And actually, you know what? Even to make this look better, because we know we want to end up with b squared minus 4ac, right? That's where that comes from in the equation. So let's just change the order of these. B squared minus 4ac all over 4a. So we're getting close because you can actually see a lot of the quadratic formula here already. We've got our b over 2a on the left side. We've got our b squared minus 4ac on the right side. So our next step is we need to divide both sides by a because we want to get rid of this a on the left side so we can solve for x. So on the left side then we'll have x plus b over 2a squared. And on the right side, when we divide by a, the a just goes in the denominator with the other 4a. So it becomes b squared minus 4ac over 4a squared. Now our next step here is we want to get rid of the square. So we're going to take the square root on both sides. So square root and square root. And we don't forget our plus or minus. So now we've got, on the left side, we have x plus b over 2a. And on the right side, we have, so on the top we have plus or minus the square root of b squared minus 4ac. And on the bottom, the square root of 4 is 2. And the square root of a squared is just a. So we have 2a. And now you can really see the quadratic formula here because our last step is we just need to subtract b over 2a from both sides. So we have x equals negative b over 2a, and then plus or minus the square root of b squared minus 4ac over 2a. And since the 2a's match in the denominators, we can combine them, and we get x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And you might recognize this because this is the quadratic formula. So this is a demonstration of where the quadratic formula comes from. And notice that we started with something we know, just standard form of a quadratic. We completed the square, and when we were done with that, we ended up with an equation for x that happens to be the quadratic formula. So this is what's called a derivation in math. You do not need to know this, but I want you to be able to see it and understand where it came from, and know that this will be the Chapter 9 extra credit problem on the test. I will just ask you to derive the quadratic formula, and you will show me this derivation. So that brings us to the end of our video for 9.5b. Try the homework, use the discriminant, and let me know if you have any questions.